Let's derive a formula for the sum of n consecutive integers. So that would be 1 plus 2 plus 3 plus 4 and so on all the way up to n. Let's first start by calling this a name, perhaps Sn. And now let's rewrite Sn, but in a slightly different way. I'm just going to rewrite it backwards this time. So first we'll start with n, and then n minus 1 plus n minus 2 plus n minus 3, and so on until we have plus 4 plus 3 plus 2 plus 1. I hope we can agree this is the same sum. And now let's add these two together. So here we'll have 1 plus n. This is just n plus 1. Then we have n minus 1 plus 2. So that's also n plus 1. And n minus 2 plus 3. This is also n plus 1. And as we see, as we keep going, we just get n plus 1, n plus 1. And here, n minus 3 plus 4, n plus 1. n minus 2 plus 3, n plus 1. And so on. And we see that this has n terms. This is the first term, the second term, the third term, all the way up to n. So this n plus 1 happens n times. Okay, and what is the other side? Well, we're just adding Sn twice. So we can rewrite this. We have 2Sn, and n times n plus 1 is just n plus 1. And that gives a formula for our sum. 1 plus 2 plus 3 plus so on is equal to n times n plus 1 over 2. Let's now verify if this formula is true using induction. So we're asking, is it true for all natural numbers, where the natural numbers are all positive integers, 1, 2, 3, 4, 5, and so on. So the first step to induction is by verifying that it's true for the first positive integer, the first natural number, 1. So let's find s of 1 using this formula. Well, s of 1, according to the formula, is just 1 times 1 plus 1 over 2. And this is just equal to 2 over 2, which is equal to 1. And the sum of just 1 is just 1. So we see that this is indeed true for S1. Now the second step to induction is we're going to assume that the formula is true for some natural number. So maybe not the ones before it, maybe not the ones after it, but let's just say it's true for one natural number, n. So Sn is equal to this. And now we want to see if it's going to be true for n plus 1 off of this formula. So let's do that. So S of n plus 1 is nothing more than just 1 plus 2 plus 3 plus so on plus n plus 1. But remember, this right here, this is just S of n. So this is S of n plus n plus 1. And what is the formula for S of n? Well, since we assumed that it was true for S of n, we can rewrite it as n times n plus 1 over 2 plus n plus 1. And now let's combine this into one fraction. So I'm going to multiply this by 1, which is the same as 2 over 2. And if we rewrite this, we'll get n plus 1 is nothing more than just n times n plus 1 plus 2 times n plus 1 over 2. And this is the same. If we factor out this n plus 1, we can get n plus 1 times n plus 2 over 2. And this right here is the same as n plus 1, and I'm going to put this in bigger brackets, times n plus 1 plus 1. So we see that this formula right here of n times n plus 1 is also true for n plus 1. I know that sounds confusing, but here we have n plus 1 times n plus 1 plus 1 over 2. And now let's take all the information that we have so far and analyze it. So we know the formula is true for n equals 1. Okay. And now, since the formula is true for 1, then it must be true for 2, since it's true for 1 plus 1. So it's true for 2. And now it must be true for 2 plus 1, so it's true for 3. And it's true for 3 plus 1, so it's true for 4. And so on. We'll see that it's true for all natural numbers.